Hello students, today we will solve some problems from quantum mechanics, de Broglie equation. At first, I will write the de Broglie equation formula. So what is de Broglie equation formula? I have written three formulas. These three formulas can be used for different problems. For your easy purpose, I have listed all the three formulas of de Broglie wavelength. So the first formula is lambda, that is de Broglie wavelength is equal to h by p, where lambda is de Broglie wavelength, h is Planck's constant, p is momentum. Now second formula, you have the h and lambda term common, only m and e are there. So E is the energy and m is the mass. And the third formula, this is written 12.26 divided by square root of V angstrom with unit, because we have converted it in the proper unit that it should come, and we have written the value directly, and divided by V. V is the potential difference. So normally question comes using only the first formula, but still I have given you all the three formulas. Now next we will take one short question which has come in the year 22-2023 or semester of MAKAUT. The question is, why do not we observe the de Broglie wavelength with a fast moving cricket ball? So if you have a cricket ball and if you are throwing very fast, so you cannot observe de Broglie wavelength coming out from the electron. Why it is so? It is a one mark question, and we will understand the logic of the answer now. So the logic is, look, a cricket ball has mass around 150 grams or nearby that. So it is very small mass compared to an electron, whereas electron mass is what? It is having very higher mass compared to electron, because electron's mass is 9.1 into 10 to the power minus 31 kg. Now you look at the formula of de Broglie wavelength, which is given by lambda is equal to h by p, where p is your momentum. Now what is the formula of momentum? Momentum's formula is mass into velocity. Remember, previously I have given one formula in which I have written square root of V, capital V, that is voltage or potential difference. And here the small v is velocity of the particle which is moving. So here we have considered a cricket ball which is moving very fast, but which mass is only 150 grams. So 150 into 10 to the power minus 3 kg. And what will happen? You know the value of the Planck's constant is 6.62 into 10 to the power minus 34 joules second. Now, if you put 150 into 10 to the power minus 3 into, for this velocity, like we cannot throw a cricket ball, even if we throw a cricket ball at the speed of say light, that is 3 into 10 to the power 8 meter per second. So that also, then also the power, that is 10 to the power minus 34, and the below the numerator power is much higher than the denominator. So it cannot balance. So the answer of that, if we consider that mass of the cricket ball is very small, for example 150 gram, so what will happen? The de Broglie wavelength value will become very small, that it will be negligible. So that is the logic you cannot observe de Broglie wavelength from a fast moving cricket ball. Because we have a speed limit of throwing a ball definitely, even if you consider the fast bowlers. You cannot throw it in a very high speed so that my denominator will balance my numerator. So that is the reason we cannot have de Broglie wavelength for a fast moving cricket ball. Now be very careful of answering it, because at the end you may observe another question, like if you found that instead of cricket ball, if it is an electron, can you observe? Yes. Why? Because electron's mass, I already said, 9.1 into 10 to the power minus 31 kg. So that will balance my numerator, and the value of lambda will be very high in that case. So you will observe. But if the mass is small and it is like for heavier side, like mass is high in case of a cricket ball compared to an electron, so we cannot observe that. So that is the reason of the answer. Now next question, we will use another problem we will solve. So this problem is repeated in many years. I have taken two versions of the question, and some years I have also written, that is MAKAUT 2008 and 2023, 24 even semester it is repeated, and there are some years which is the questions are repeated. I have written two sets, both has the same question, the language is different. So the question is what? If a proton and an electron has same de Broglie wavelength, which one has more energy? This is one question. Other question, the same question written by changing the language, you see. This is the question is, an electron and proton has same de Broglie wavelength. Prove that the energy of the electron is greater. So how it is so? So they are telling de Broglie wavelength of electron and proton, if it is same, you have to check what is their energy, both for electron and the proton. And then you have to say that which one has greater energy. So let us see what happens. We will consider two things. Mass of the electron as Me, mass of the proton as MP. Now de Broglie wavelength of the electron we can write h divided by momentum, that is mass of the electron Me, and V is the speed of the electron or velocity of the electron. And similarly for the proton we will write the de Broglie wavelength lambda p for proton equals to h by mass of the proton mp into velocity of the proton vp. So if that is so, we will use the condition in the question they given us. They gave us the condition electron's de Broglie wavelength equal to the proton's de Broglie wavelength, means lambda E equal to lambda P. So if that is so, from here we have already written what is lambda E and what is lambda P. So if you have written this thing, you look at here, that is h by MEVE is equal to h by MPVP. You cancel h and you can equate MEVE is equal to MPVP. I have given it equation number 1. Now you see, this is a known formula. Kinetic energy of an electron is equal to half mass into velocity square. That is a known formula. Now in this equation, what I will do is I will write the velocity of VE from equation 1. So how we will write? We will write half of MEV square means half of ME VE into VE. So if that is so, I can write half of MP VP because ME VE equal to MP VP. So that I have written here into, again VE is there. So this part I will be writing, look at here, if ME VE equal to MP VP, then VE is equal to MP into VP divided by ME from equation 1. So using this, I can write here MP divided by ME into half of, you just check this equation here and you will be getting this line, half of MP into VP, so VP square coming here. So if this is coming here, now you can write here, you have already written kinetic of energy of the electron is equal to half of ME VE square. Now in this term you are seeing half of MP into VP square, mass of the proton into velocity of the proton square. So this part I can write as kinetic energy of a proton or energy of a proton. So MP by ME into energy of a proton I can write after solving this equation. Now this is a note for you, you do not need to write in exam, but this is a note to you to remember that mass of proton is equal to 1.67 into 10 to the power minus 27 kg and mass of electron equals to 9.1 into 10 to the power minus 31 kg. So here you can see the power is minus and the lesser number is the higher mass. So we can write, since mass of proton is greater than mass of electron, the energy of an electron is greater than that of a proton corresponding to same energy. Means if you have the energies are same and MP and ME are the defining factor of the who is having the more energy. So like even if we both the equations are, you have the same energy, but because mass of the proton is higher and mass of the electron is smaller, so what will happen? This whole thing will have higher value. As a result, kinetic energy of the electron will be much greater. So that is the question. So so what they are showing, the energy of an electron is greater than that of the proton corresponding to same energy. So this is our answer of this question, and the marks allotted in that year of the exam is 5 marks. So I hope you understand this equation, this problem, and thank you so much.